Welcome to the session on Microsoft Access. Top 10. Well, that is one of the top 10 devs mistakes that won't scale. But we want and end users, end user mistakes that won't scale. Yes, all right, we got people filtering in, so I'm going to go ahead and get started because plus the beginning is the boring introduction part about me that nobody ever really wants to hear anyway. I am Brent Ozar, work for Quest Software, and I'm a SQL Server expert, which is just about the coolest job title in the world. All I do is keep learning SQL Server and how to make you guys' lives easier. Up until about 2 years ago, I was a production DBA out in the field for Southern Wine and Spirits. If you're going to be a DBA for a company, that's a pretty good company to database administer for. All my stuff was Chardonnay, beer, vodka, Jägermeister, for that matter, in my database. Managed the SQL Server's SAN, storage area network, and VMware for this $7 billion company. We had a lot of internal web apps, and since then I've also worked for a lot of other companies as well. I do consulting on the side, so I've worked with companies like Stack Overflow and Fog Creek to try and make their databases run better. We currently do a lot of work on 10 terabyte data warehouses. So I get a lot of opportunities to see things that aren't going to scale, things that are going to explode when they go into production. And I'm the one who gets called in afterwards, after the app that you built and you thought, oh, this is only going to have 100 users, and then 5 company mergers later, because you know how it works with your code, everybody loves your work, and nobody can get enough of it. And it's going to be massively popular, but you don't think that in the beginning because you're so humble, and you think, oh, this is just a little something I whipped up, and next thing you know, it's all over the intertubes. So I blog over at brentozar.com, and I'm on Twitter at Brento, and of course Twitter is completely crashed today. And if you're going to have a SQL Server book, this is the one you want to have because it's got a race car on the cover. Doesn't get any better than that. But before I get started in this, I need to draw a difference between 2 words, because I know that out of these 10 things that I'm going to tell you about, a lot of you guys are doing some of this stuff, and you think it's going to work just fine. But I want to talk about the difference between the word probable and the word possible. Is it possible that this feature will scale, or is it probable that this feature will scale? I don't know about you, but I know some developers, especially guys in my shop, people that I've worked with, that absolutely everything they touch turns to gold. These guys can code anything, any way possible, and you'll look at the code and you'll say, I don't even understand how to read this, let alone what it's doing or whether or not it's going to scale, and the stuff just takes off and flies like crazy. This presentation is not for those guys. This presentation is for the rest of us. This is for the presentation for those of us who we're just struggling to make it through our daily jobs, to get things to work without having them explode, and we may not have the best tools in our toolkit, and we just want to set ourselves up for success. So the 10 things that I'm going to talk about today, and I'm going to step through these so you don't have to jump through all these lists immediately in order. Everything that I'm going to cover is things that can scale, but I'm going to show you why you want to avoid jumping into them initially so that you have the best probability to scale right from the get-go. And everything that I'm going to talk, doggone it, there's a missing slide in there. All right. So we're going to start with number 10 on the list, which is triggers. And I start with this because this is one of those religious issues that it's very easy for a DBA to say, of course that's not going to scale. So we're all going to have a relatively easy time agreeing on this one. Now, I like triggers. The reason that I like triggers is that they have business logic built into them that I can enforce every single time. If I'm working with some third-party app, and not that third-party apps aren't perfect, but sometimes I have to take over third-party apps that have bad code, and I go, oh, you know what? I wish I could track the history of customers. Whenever anybody adds a new customer, adds a new user, or changes an existing user, I want to capture that, and I want to put it in an archive table somewhere. And I'm a really bad developer, and so I may not have access to the source code that's actually doing this work, but as a SQL Server database administrator, I can go behind the scenes of the developers and just write a trigger to make these things happen. And whenever there's an insert, update, or delete, I capture that information and I put it into an archive table. And it's great because it happens instantaneously and it's completely transparent to the end users and developers. When I write a trigger, everything just happens automatically every time, and I guarantee that you can't add a user or customer or product or whatever without my trigger firing and taking care of business. Well, those are good things, but the bad things about triggers, the reasons why they won't scale, is first off, you can't uncouple that timing and processing. What happens when your company runs a Super Bowl sale and all of a sudden you have 1 million people pouring in at once and you're trying to add these customers as fast as you can, and you just wish that you could offload some of that processing somewhere else? And you can't do it with a trigger. You simply can't keep pouring in data unless you say, oh, you know what, I remember there's a trigger on that table. I'm going to go manually delete that or disable it while my work is running. Oh, I was going to say, he can't be taking a picture of me. I'm certainly not that attractive. See, that tells you how attractive I am. He's taking a picture of the guy on the slide rather than me. It's either that or, yeah, he's got that kind of taste in men, I suppose. And there's, or maybe it's him. It's the first time he's ever been on a slide deck. SQL rock star, ladies and gentlemen, right in the front row. So the next problem with triggers is that there's really not very good error handling. When something goes wrong with that trigger, things are going to explode and your inserts, updates, and deletes aren't going to happen seamlessly. And this really becomes important when you're trying to insert, update, or delete multiple records at a time. And most people don't think about this, and their trigger code looks like this. Can anybody spot where this is going to break?
Create trigger?
Yes. Create trigger is good.
Select view status equals select status name. That could possibly return more than one.
Absolutely. So he points out, give this man a Starbucks gift card, Tim. I have a lovely assistant up here in the front row, Tim Ford, who is going to be handing out, lovely is a strong word, but going to be handing out Starbucks gift cards for people who ask questions or answer questions that I deem worthy of caffeine. Maybe that's not such a compliment there. Now that I think about it, probably a bad gift choice. Not that you need caffeine. So the problem that he pointed out is when I say select status name from inserted, I have no clue which inserted record I'm going to get. I see people write triggers like this that they're thinking one record gets inserted at a time. There's a web app that just goes and inserts a new user because we got a new person hired. And I want to say if that user is inactive, I want to roll them straight back. I don't want to allow that to happen. But what happens when my insert statement, the source of that is a select? So all of a sudden, I'm pouring in 20, 30, 40, 100 records, and I just do select status name from inserted. I have no idea which status I'm going to get. So if I've got one inactive user and 19 active users, who knows whether or not this trigger is going to fire correctly. So if you're going to go so far as using triggers, please test them with multiple records simultaneously. And there's ways that you can make this work, but they certainly aren't elegant, because now you're going to have to be going through that 20 record inserted table and figuring out which ones need to have which business logic applied to them, and boom, that will not scale. That's an instant recipe for disaster. Now, there's a lot of good alternatives to triggers. Well, not a lot. There's at least a few. First off, a SQL agent job. Now, what I mean by that is maybe I want to have a job that runs every 60 seconds, checks to see if there's users that have been inserted, and if they have a status that I don't like inactive, I go fire off an email address to somebody, or I set some kind of flag in a table saying, this needs attention. Now, this is about the worst alternative I've got. But when I'm just getting started putting training wheels on and I'm trying to get rid of my triggers, this is an easy place to get started. The second thing to think about is use an application server, bundle all as much logic as you can in your web tier or whatever third tier, or the middle tier that you're using. Because SQL Server, here's a news flash that you're not going to hear from any of the Microsoft presenters today, is very, very expensive. Especially relative to all of your IIS servers. You know, you guys, so often our stuff is a dime a dozen in the middle tier, but that database tier at $30,000 a socket for Enterprise Edition, that adds up real fast. And the more that I can move that code out of SQL Server, anytime I need to do processing, I want that out of SQL Server, because it's something that I can scale much easier in the middle tier. And then finally, I'm going to come bring it back into SQL Server here is with Service Broker. An excellent Service Broker guy is Denny Cherry here in the front row, actually. Say hi, Denny. So if you, hi, Denny. So if you want to have an asynchronous trigger, that's really the best way that I can explain Service Broker is when something happens inside my database, I need to do work, but maybe not right now. Maybe a second from now, maybe 5 seconds from now, maybe even a minute or two from now. Service Broker is a great way to implement an asynchronous trigger that you can offload work off your SQL Server. And if you're interested in learning more about how that works, talk to Denny up here, and he's got a whole lot of experience on that exact topic. Now, as I go through here, if you've got any questions, feel free to stop me. I have a rambling, very fast way of speaking, so I go a mile a minute. But we will have time for questions again at the end, but feel free to stop me if you've got anything. The next thing on our top 10 list is select star. And you read about this in all the books, and you hear the DBAs. How many of you guys here are developers? All right, how many of you are DBAs? Okay, see, so there's a minority here. Usually when I talk, I'm a database administrator. I used to be a developer, and I got out of it in the classic ASP days when I figured out I was going to have to relearn a new technology every single year, 2 years, 3 years. Like Java, .NET, it's all so complicated. Why don't I just go to database administration where they don't ever have to learn anything? It's just T-SQL over and over. So the DBAs out there will tell you guys that don't ever do select star. It's a really bad idea. Well, I'm going to show you why it's a really bad idea. Here I've got two queries that are essentially identical coming off the Stack Overflow public data export. The top gives me select top 100 star, and in the bottom one I'm saying select top 100 star or select top 100 tags and ID. I'm just fetching the exact specific fields that I need. Now, if I look at the query execution plans for both of these, a neat feature in SQL Server Management Studio is you can put two queries right in a row and then display estimated execution plan. And then notice the highlighted circles, it'll compare the two plans. So it'll tell you which one of them represents the bulk of the work. So the top one is select top 100 star, and the bottom one is just picking the fields that I need. And notice that the top one is 98% of our overall costs. Or for the slow DBA math guys in the room, I'll break it down. That's 50 times, well, 48 times, more expensive, 49 times. See, I'm a database administrator. That's why I'm not, strike three. That's why I'm not teaching math. 49 times more expensive in the top one. Now, why is that? Because in the bottom one, I can do an index seek and use what's called a covering index. I don't have to go back to the base table to say, give me all of the fields that describe a post, because all I need is these two, and they're included on the index. 49 times faster means your application can scale 49 times higher. 49 times more users, more simultaneous queries that you can use if you just knock off the star. But wait, there's more. Not only does it knock you off from not being able to do index seeks, it also hoses up the missing index DMVs. Now, your database administrators are lazy. And so what they do is they query the SQL Server DMVs, dynamic management views, to tell them what indexes they should add. When you think they're really doing hard work to tune your database engine, all they're really doing is selecting this and doing exactly what SQL Server tells them to do. But the problem is they're going to get bad results out of that when you're doing select star, because they can't predict what fields you really need. If you just named the 4, 5, 6, 10 fields that you needed in your select statement, the missing index DMVs will say, hey, our developers are constantly querying for these fields in this order. Here's the index we should add. Whereas if you don't and you do the select star, it's going to recommend a ridiculously wide index with all kinds of fields on it, and your DBA will say, no, I'm not doing that because it's too intensive on my database. Go ahead, back there.
What if you're using link and you fill out pretty much the whole object on link to SQL? Is it actually querying out the whole object, or is it?
Oh, this is so sad. Oh, we've got an answer back. Go ahead, fire away.
What happens with link? Linking can actually form your SQL where you do a select star, it is going to submit each field name. If you look under the curve, each field name in there. So it's a precise query. That's where link gives you the advantage of performance versus, say, the data sets. Because you do a select star and
So the question was, if you use link to SQL or link, and you just grab objects out of the database, is it going to grab all of the fields? Is it going to do the select star? Is it going to name fields individually? And the same thing with entity framework. And the answer from the back is that link is smart enough to pick individual fields, and I don't know that for certain, so I'm going to take his answer. But I'm going to come back to this in the very last step and show you why you might want to think twice about that whole discussion as well. And I'm not against link. We use that at Stack Overflow, for example. And then finally, the last problem there is, oh, go ahead, back in the back.
Is the performance improvement that you demonstrated earlier primarily because the index covered all the fields you wanted?
Exactly, yes.
So if you wanted to select total host,
Yes.
is there a performance or scalability benefit if you select each field out individually, even though you're going to select every single field?
That's a great question. Jeremiah Peshka likes to say a good question is answered somewhere later in my deck. A great question is answered right now. So the great question, I'm glad you asked. The last one added fields to tables. So you know what happens. You get done with your development work, you think everything's done, and then the DBA goes behind you and adds 5 more fields. Or some other developer goes in and behind you and adds 5 more fields. If you didn't need those, that's where the benefit comes in of naming just the fields you need instead of doing a select star across all of there. And it's really bad when I see people go back and add var max, var binary max. They throw all kinds of data in there later, and somebody else who's just doing a lookup table that only needed like state name and state ID. They didn't need a picture of the state, and all of a sudden they're shuffling all this data back and forth between tiers, and it would have been better if they just named the fields they needed. Great question. Give that man a Starbucks gift card, actually. He's on the left-hand side. Yep, there we go. He's not raising it very high for a Starbucks gift card. Yes.
When I'm working with developers as a DBA, I'll include a large var binary field, and I'll put the Trollolo video.
I like that.
Do a select star, they get Trollolo.
Buck Woody says that he does what he does is he puts a var binary max at the end as the last field no matter what, and puts the Trollolo video in there as a binary, so that way you always get it, and that'll teach you. So that, what are these results? Oh my God, my eyes! How many of you guys have seen the Trollolo video? Oh, I should play that now, but I won't. So that's how I never got invited back to Tech Ed again. So that's the problems with select star there. Next up on our list of notorious problems, scalar UDFs. Now, scalar UDFs are like the tip of the iceberg. When I see somebody using these, they're buried under programmability in SQL Server Management Studio for a reason. I want you to start thinking of user-defined functions as stored procedures. People look at stored procedures and they say, oh, I have to optimize this. There's big ugly code in here. There could be thousands of lines in here. UDFs are a whole lot worse because you may call them a whole lot more often. This is an execution plan of a query that has a scalar UDF in it. Because of the way that it was written, it's only doing an index seek down at the bottom. Now, database administrators, again, because they're not very bright, aren't going to read this and know that's a scalar UDF and that's a problem. They're going to, did you just give me the finger? I think you did. Index seek, he's going to say, that's great, there's not a problem with that. But if they take the time to hover over each individual part of the execution plan, notice that some of these may be run a whole lot of times. This particular one is running this one same index seek roughly 274 times. And if I'm running that across a 1,000,000 row table, it can happen a whole lot more than that. And it all comes down to where you put that UDF. If you put it in the joins, if you put it in the where clause, whether you put it on the left or right of the where clause, and what other tables SQL Server can eliminate from this first before it starts calling your UDF. Now, the alternatives to that, because people often use this in order to do code reuse, first off, if you're constantly calculating something, consider doing persisted calculated fields. Persisted calculated fields are something that when you set it up on the schema of your table, SQL Server will calculate it once when that value goes in, and that's it. It stays on disk for you to query later. It's almost like a field that SQL Server is calculating permanently for you instead of having to do it every single time you query. The next is persisted indexed views, and us DBAs, we kind of have a love-hate relationship with these, because if I have a 1,000,000 row table and I have another 1,000,000 row table and I try to do a persisted indexed view across that, that's a whole lot more storage that I'm going to need, and if either of those tables changes, I have to change rows in that persisted indexed view. But if I'm constantly having to call a UDF, this can be a faster way to do it.
Where does that magic point live?
Where does the magic point?
I have a 70 million row table.
You're the guy.
And I have we have this one user function that not only do they search on with wildcards.
Oh.
The way the U.S. financial markets work.
Yeah.
And
Yeah.
so they will run, and they generate their SQL because, God forbid, we use this procedure.
Yeah.
And so we've had the index view discussion, but because of the number of records we write every day, do I want to take the I/O write hit versus because I got to get all that stuff in there as fast as humanly possible versus do I take the read hit because the read stuff is more reporting and not as important?
So I have a unique perspective on that. It's a really neat time to be both in database administrators and SANs. He was asking what the tipping point is between when you go with an index view versus when you try and take the hit on the fly. It is a really cool time to be in storage because of solid state drives. Now there's several vendors that will sell you PCI Express solid state drives. They're not that expensive. They're expensive when we look at them for our personal computer, but they're not that bad when you look at them in terms of SQL Server licensing where, it's like an arm and a leg for buying these things. Indexed views are an awesome candidate to land on solid state storage because some of these are not terribly reliable. Some of the solid state storage gear that's out there right now. It's still very young in its infancy, especially the PCI Express stuff. So if my index view dies, I may not really care because I can regenerate that fairly quickly. Whereas I don't want to land my production data on there necessarily. So what I go down to making the judgment call is, where is the biggest bottleneck on my box right now? And then can I alleviate that by throwing in something like a solid state drive and landing it there? I guess he's worth a Starbucks card. I got a whole pile of them, so I got to get rid of them. I don't have to get rid of them. I can take them home with me. In which case, you guys will come afterwards with all kinds of questions.
You've had a pile of them.
I had them. Oh, you're giving them away already, aren't you? You're ordering in. Scurrying favors. He's promising them out over Twitter. Five Starbucks cards to. So then the next option that you can use to fix these is an ETL process. If you're doing something like a data warehouse, when you're doing your nightly loads, do this on your SSIS server. Rather than trying to calculate this stuff on the fly, even though it's great for code reuse, just calculate it in the beginning, take the hit, and then query the data, especially when it's going to sit around for years and not change, like in the course of a data warehouse. And then finally, just optimize the bejesus out of them. When I see 100 stored procedures and I see 100 user-defined functions, I am more likely to look very closely at the scalar UDFs because those get called more often. If somebody's got it on the select or where clause, this thing is getting constantly called thousands, millions, billions of times per day, and I want to fix that because every single line I can save out of there, every substring, every left and right call that I'm trying to make out of there is a huge performance hit, and it'll add up very quickly over time. It's the old death by 1,000 cuts performance tuning scenario. So next up on our list, dynamic T-SQL. Now, how many of you guys are using dynamic T-SQL? Oh, there's a lot. So how many of you know? Well, we'll just go through it. So first off, in a nutshell, you're looking at declaring a string variable, like I'm doing here, declare string varchar 1,000 or 100. And I'm saying set that to select star from authors, which of course is already bad because I'm saying select star. And then I'm telling SQL Server, okay, go execute that string. Now, this is really a pretty straightforward version, and there's not a whole lot that can go wrong here. But what a lot of people don't know is that SQL Server will save different execution plans if you've got comments, different numbers of spaces, different case orders if you're on a case-sensitive server. Almost any variation in that string, even though it executes the same way, will get a different cached execution plan. And the more execution plans you cache, the less space there is in your plan cache for other queries. Even though this stuff is totally redundant, SQL Server will still calculate and store different plans in the cache. So when you're building these T-SQL strings, it is imperative that everybody use the same spacing, casing, and everything else throughout their tool. If you've got a 3,000-4,000 line set of C# code that's generating dynamic T-SQL, go through there and optimize that as closely as you can so that when you're tacking on where clauses, they look identical. The next problem with it, though, is our old good friend Bobby Tables. And this isn't necessarily a problem with things that don't scale, it's a problem with things that just flat out don't work. So often I see people with a web app where you've got the little up and down arrows for sorting by price or by rating on something. And when you click on that, it literally sends behind the scenes an order by price descending or order by customer name descending. And all it takes is some bozo to put in something in there like drop tables in the order by string, and presto, your tables are gone. And this is something that's basic security 101, but if you're doing dynamic T-SQL at all, I urge you to go get educated on how that works. The place that you can go get educated on it is Erland Sommerskog. He's a SQL Server MVP, excellent writer, has a huge long article on dynamic T-SQL. And you don't have to write this down directly because I've got links to this slide deck, plus all of my notes, plus all of the links that I've got in here. I've got a link at the end. So that's my little encouragement to make you stay till the end. Or watch the video. So one way you can fix it is build stored procs, and I don't mean move the dynamic SQL building inside the stored proc. I mean, if you've got something that you call fairly frequently, persist the thing. Put it into a stored procedure so that you can go make your database administrator tune that thing. You can say, there's the stored proc. I'm not going to change it. You go code it whatever way you want to make it faster, and that way it's like unit testing for database administrators. They can just go in there, make whatever changes that they want to make, and it's up to you guys to see, hey, does this thing still return the same results when I call it back? But definitely check out Erland's fantastic blog post there. Oh, back in the back. If you parameterize the queries, does that remove the... Go ahead, I couldn't hear the last of it. Yes. If you parameterize the queries, does it remove the ability for SQL injection? Yes. I'm not saying that that's still a good idea, though. I still don't like it for other reasons. Hey, go ahead.
On your last slide, you said move it into the code. We actually had a case where we had to do the opposite. Of course, the users want to search and filter by everything. Million record tables. So we had to move it into a parameterized query. And that was so that we get a better cache hit ratio.
So that's interesting. So if the objective is to get a better cache hit ratio, so there's this lumpy data problem. Let's say that you've got a data warehouse and you've got data for every state of the union, for sales, for paper clips for the last 10 years. And when a user passes in a query for Rhode Island, SQL Server builds an execution plan based on the statistics for Rhode Island. And when somebody else turns around and calls it for Texas, if this thing is parameterized, SQL Server may not realize, oh, that's a completely different data set and I need to build a different execution plan. So how many times have you had episodes where all of a sudden a single query's performance will go fantastically or will go absolutely poorly just for random reasons, even with the same parameters? The reason why one of these things can happen is, let's say that you restart the SQL Server, somebody calls that stored proc for Texas the first time, SQL Server will cache an execution plan for Texas, and everybody gets to use it. But if somebody restarts that SQL Server instance again, the first time it's called for Rhode Island, you'll get an execution plan for Rhode Island. And that's not going to scale well when you're constantly going back and forth trying to see, hey, what's the execution plan look like today and why? There's parameters that you can put onto the stored proc for things like with recompile or option recompile. You can put optimize for an unknown is another one that people like to use. But when you start doing that, it starts getting a little hairy, and that's when I'd rather have application guys put it into their own code so the SQL Server will look at it each time and build a better plan. Now, we got all kinds of questions here. Fire away. Oh, get that man a Starbucks gift card. Yes. What would I recommend as an alternative path? I like that in the application. I think it's okay. If you build it in the application instead of, where I hate it is where somebody will build a stored procedure and they'll have 1,000 parameters. They'll have customer name, state name, address name, person's name, whatever, and they'll have this giant if null thing going on inside of the stored procedure, and that's a recipe for bad plans. Whereas if you're doing that in the application side and you pass in one nice crisp SQL string, SQL Server will cache the plan for that string instead of caching a crappy plan for that stored procedure. There's another one over here. I have, and unfortunately it's beyond the scale of what I can do here, though. That's force parameterization. If optimizing for ad hoc is another thing you can look at there. So the next one on our nasty list is big fields. So I'll take you through a typical design scenario. Somebody will say, I've got an employees table and I really just need a field for active. Is active and it's going to be bit yes or no? Well, maybe I might need something for new hires or somebody who's about to retire. So maybe I'll just make this a tiny int and I'll point it over to another lookup table. Well, just for scalability, we standardized on all of our ID fields so that they're all integers, so I'll just make it an int. And next thing you know, you've had this huge feature creep of something that really shouldn't take that much storage, but you're using much bigger fields than you need to use. And the really nasty one is, people saw a while ago, got addicted to this nvarchar thing where they'd say, oh, sooner or later I'm going to want to store some other character set, or I'm going to want to store international data in there, so I might as well just go ahead and use nvarchar now, not realizing that it immediately takes twice the storage and makes your tables twice as big, or those fields twice as big as they need to be, when you may not be storing anything but plain old American English in there. This really has a big problem. Michelle Ufford, SQL Fool on Twitter, has a fantastic write-up that she did of a case study before and after showing how correctly designing her fields from the get-go was able to shave a massive amount of performance off of her application. And I've got a link to that study there at brentozar.com/go/bigfields. And if you were in Buck Woody's design session yesterday, database design session, one of the things that we talked about, that he talked about, I didn't talk about, well, I guess he asked me a question. But you lay out all your nouns and verbs, and the last thing that you want to do is pick your data types, because so often that's going to be wrong along the way. If you try and go and pick it early and just say, oh, I'm going to need a varchar 100, or oh, I'm going to need a big int, you're probably going to be wrong. And if you go back through and look at these, you can cram them into smaller fields so often. But what you run into is you probably already got all this code that does things like build temp tables or build arrays in your application where you're expecting fields a certain way. And when the DBA goes behind the scenes and starts tweaking your fields, he can very easily send you something that's too large or too large for whatever you're trying to store. You can either send data that's too large in, or he can send you data that's too large back out. So this is where, go ahead.
What about XML?
Oh, what about XML? I am okay with XML as a property bag. It's when you try to query it and make it scale. Have any of you guys written a large scale, say terabyte database with XML? No, and it just does not scale as well as you would want it to. I love it in theory, I just don't love it in practice. If you want to store property bags, so a thing with a property bag is, for example, let's say that we're gathering customer data and we're doing it via handheld survey, and the people at the on-site can change that survey at any time and add more demographics questions, like did you like the pool, or did you like the drinks of the Hurricanes last night? And we can't predict what's coming in. That's called a property bag. And we just store that whole lump of data in XML, and we can go back and get whatever happens to be there later. XML's fantastic for that. But if I know in a rigid defined sense that I'm going to gather gender, address, city, state, zip, whatever it is, fields that are commonly used, persist them in the database so that we can index them and they'll perform a whole lot better. That definitely deserves a Starbucks card. Although Tim is off doing Twitter. Is Twitter back up yet? No. It is. Just talking about me. Doesn't everybody? All the time. And the other problem with big fields is that just like having too many indexes on a table, the bigger your fields are, the less data SQL Server can fit on an 8K page, and your tables get bigger, which means longer backup times, tougher disaster recovery options, longer DBCCs, and longer index rebuilds. So when your DBA is coming and complaining to you saying, it takes me 6 hours to back up this database every night, having the right size fields really does make a difference in how this thing will perform. Next up on our, go ahead. Yes.
We have an app that has a XML column in it.
Yes.
Basically, with every page first. Is it worth it to move that XML to another table and join every time to keep the table small? To allow some of the searches, maybe, let's say the local business to return more quickly.
That's an excellent question. So if you have a table with a field in it and it's got XML, is it worth it to move it off to a separate table? Now, it's interesting how this works. if you have, depending on your version of SQL Server and how things are set up, that may be already stored what's called off-row, and it won't make your pages any smaller by moving it off to another table, but it will help you in terms of index rebuild times, so that it won't take as long to rebuild the table if it doesn't have the indexes on there. If I had to make the decision, I would probably do two things. I would move it off to another table, and I would put it on slower storage. I would tell my SAN guys, you can leave this on cheap SATA drives in a RAID 5, because I may not care as much about how quick it takes to return that, but I'm very passionate about how long it takes to return my core set of data that I query all the time. So I want to put that on extremely fast storage, use as much money as I can for that fast storage, and put the XML stuff that I maybe not query as often onto a slower set of disks. And I would make that recommendation no matter whether it's XML or anything else. If you have a large amount of data, a whole lot of columns, that's where you start talking about normalization and how you want to separate those. And you may not always want to just normalize by design theories. You may also want to do it by backup and recovery options, because you may want to be able, there's this feature in Enterprise Edition called Online Piecemeal Restore, where you can restore individual file groups one at a time. You may want to get just the core set of data online immediately and say, I'll take that XML later whenever I can get it. Oh, that's a very good question. Go ahead, fire away with the Starbucks card. Go ahead.
I would say, as a DBA, I'm not concerned anymore so much about storage of large fields, because with enterprise, I can turn on compression.
Oh, okay. Yeah.
Which, not obviously, it's still not good. I don't want the developers to know that I can do that.
Yeah.
But it's an option there that they're using varchar and varchar can, even if it's a single byte character.
But it still affects your online piecemeal restore, and now you're taking a CPU hit on doing that, and it doesn't work with OLTP loads. So he brought up the point of data compression, and it also doesn't work with binaries. So if somebody's throwing binaries in the database, which segues me excellently to binaries in the database. So, of course, SharePoint's all over this conference. Everybody loves SharePoint. It rocks. What? Oh, somebody's got a question back there? Oh. Yeah. Well, you know, and it's funny. They've made these improvements that I'll talk about here in a second. But so the problem with SharePoint, with a whole lot of other software like fax software, is that as data comes in, Word docs, Excel docs, images of faxes, medical images, we want to store them in SQL Server because we're really good at backup and recovery. I can do transaction log backups and get you right to a specific point in time, right before Johnny deleted that bad copy of the spreadsheet or all the proof that he'd ever been taking money out of the bank account. So that I like about putting binaries in the database, but the nasty, dirty truth is that this thing does not scale in terms of backup and recovery. How many of you guys have tried managing a SharePoint database and doing backup and recovery? A few guys. How many of you like doing that? A lot of hands go down. So if you're a developer and you're thinking about putting any binaries in the database, take the word of the DBAs who try to manage SharePoint databases. It is an unbelievable pain when it comes to backup and recovery. The more stuff that we cram inside the database, the longer it takes us to do all of those operations I described. DBCCs, backups, restores, index rebuilds, any kind of maintenance window goes through the roof. Now there's some alternatives here, but these are really kind of a little tricky. First off, SQL Server 2008 introduced something called file stream, which lets us put binaries in the database, but they actually sit on a file share. So now my MDF file is small, but those data files live on the drive on the SQL Server. Now that might sound good, but if you've played with this, I'll give you a little hint. Go in there into Windows Explorer, store some data under file stream. You'll notice that they have GUID names. Copy that name, delete the file, use Notepad to create a new file with the same name, and then do a DBCC check or check your error logs. SQL Server has no idea that anything happened. This is only as secure as your security settings are on that SQL Server itself. If you've got bozos who can still go in there, use Windows Explorer and screw around with things, or if that storage isn't perfect, there is no backup plan other than your backups, and your backups still take just as long whether you put the stuff in a database or whether you offloaded it off onto a file stream. We have to back it up one way or another, and it still takes just as long. So the next improvement was remote blob storage, which this is a relatively new thing, pretty much for the SharePoint team, if I remember correctly. that lets us dump stuff into something like an EMC Centera that just acts as a file server. And SQL Server says, I'm going to take this data and I'm going to throw it over there on this Centera. But really, it's not a whole lot different than FileStream, other than that Centera probably has tools to help you back it up a whole heck of a lot easier. Are you using one of those? Yes, Denny's using one of those. So that's better, but what I really want to steer you towards is storing pointers, not files. Let your end users upload whatever they want, but land that on a file server somewhere, preferably one that's equipped with Windows DFS, distributed file storage, so that your Windows admins can land that file across multiple servers simultaneously and cache it in different offices simultaneously, which is not something we can do easily with SQL Server. I can't throw a switch and start having multiple SQL servers in load balancing configurations easily. That's a real pain in the rear. So moving yourself more towards a content distribution system like Windows DFS is the right way to go. Go ahead back there. Are you just aiming for another gift card?
Give me one.
All right.
Do you have an opinion on storing, literal, or even relevant, like actual file paths that with file name and extension versus using a pattern where you say, we're going to store some information about profile, and you say, well, I know the profile name should be named the user, space replacement underscore dot. Scalability problems with that, you mentioned things like file streams and change the file around.
Yeah, the reason that, okay, so the question was, do I prefer using a coded name for the file location, for example, like %system, and then whatever, or user directory, then whatever. I'm not as worried about that because in SQL Server I can always issue an update statement and correct things to change patterns, so that doesn't break my heart. But I like using the full file name just so that I can more quickly do troubleshooting, the full file path. And with DFS, the way DFS works is it looks like a server name. It's whack whatever, whack server 1, whack share. Well, it's actually whack domain /share. But it'll work from anywhere, and your Windows admins can move that from server to server without you knowing. So it's much easier in terms of administration. And then I like breaking up the duties so that my developers manage the code, my Windows guys manage what they do really well, which is file backups. They're fantastic at that and high availability for that. And my database administrators can manage the data. Go ahead.
To that question, albeit this was SQL Server 7.0,
Oh.
back before the earthquake, we had the largest optical install in the world for property records in Southern California, and we indexed it on SQL Server. And the big advantage of putting your full path in that field is if we lost a platter, we lost a cabinet, it was so much easier to go in and correct the path than doing a pattern search or everything else, because albeit this was 7.0, this was 20 million documents, everything from OJ's lien, Berkeley Goldman's. It used to be our test case software,
Wow.
everything else, but there were so many, it was so much quicker than trying to do a pattern replace or anything else, just to find, okay, I know this platter, go in, correct it, and you were done 1, 2, 3.
I do like that. So he pointed out that if you've got the exact path in there, and for example, you know that a specific folder failed or a specific server failed, you can find that much easier instead of doing a search and replace. Because whenever anything fails, you want to. It is an iPad. Boy, how many people in here have iPads? Look at that. I love you people. You're my people. But that way you can find things a whole lot faster, because in the event of a disaster, you're always freaked out. Those things are always nasty. Oh, go ahead.
Just one other thing about that.
Yes.
You might want to consider file size. You start getting yourself 500 gigs worth of 15K files, off of a scanner or something. It's a lot faster to have that actually in a SQL Server database and be backing that up as it is to have something dying trying to back up all of the 15K files.
So I'm going to disagree with you there. He said that he would rather have, say, 500 gigs of 15K files inside the database instead of on the storage, because as a SAN guy, nobody can ever. How many of you guys like your SAN guys? Yeah, pretty quiet in here, hardly. Yeah, because Denny is the SAN guy, and he likes himself. So when I'm a SAN admin, I have a whole lot of tools to help me do like snapshot backups, where I can capture a whole LUN instantaneously, cleanly, and I can't do that with SQL Server as easily, or I have to do repetitive snapshots over time. It's so much easier to manage that when it's inside the file and print servers. So much easier. And then don't even get me started about the wasted space on the page, because you hit a perfect number, 15K. So yeah, exactly. You see where I'm going with that. So binaries in the, oh, I hit the rewind. I was like, boy, that seems awfully familiar. Next problem that we have is heaps. Now, heaps are tables without clustered indexes. Now, by default, most of us probably know we're not supposed to do that, but we don't really go back and look behind the scenes to see, did every table that last guy, because you know the last guy was always an idiot, did every table the last guy create have a clustered index? He's laughing because he was the last guy. Did all of them have a clustered index? Because if they don't, this is what your database looks like. Your stuff is organized on disk in essentially random order. I want you to think about a phone book that's literally laid out in random order. And trying to find anything is like trying to find a needle in a haystack unless you've got an index that's absolutely perfectly relevant. You're constantly going to have to do table scans, especially when you're doing inserts, updates, and deletes, looking around for some of this stuff. Now, it's very, very simple to fix this problem. Now, there's niche places. How many of you guys actually like using heaps? Because there's always some of these religious zealots. Oh, there's nobody in here. So if anybody tells you they just love heaps, they're a religious zealot. And you can go find their work with this query. Now, don't worry, I've got this. This is on my website, plus I've got a link to it on the last slide, brentozar.co/go/find heaps. And it will just zip through your database and tell you all of the objects that don't have a clustered index. And I want you to go through and add one. And it's very easy. First off, look for identity fields. So often, these bozo last guys put on an identity field in there thinking, oh, my table ID, and then they just never turned around and made it the clustered index. Go ahead, right there.
What's worse, having a heap or having a clustered index on a grid or something like that?
It depends.
Because you said primary keys, and I can't tell you the number of times the database is just, okay, we'll do the clustered index with primary key, default, or grid, and I don't know which is worse.
Kimberly Tripp has a saying that there's, like, in terms of the levels of how bad things are, the worst thing is a bad primary key, bad clustered index. The next worst thing is a heap, and the next best thing is a good clustered index. One of the nice things about a good, ironically, is that it does not change. It's static. Whereas if somebody puts a clustered index on something that's constantly changing, like total sales, and it'll move all over the place, every time you update total sales, SQL Server has to pick that record up and move it along somewhere else. So it always depends on how what you've got available to you, whether it's narrow and whether it's stable. So like ideally I want an int that never changes, like an identity field, or at least something that never changes, but I want to get away from using goods as primary keys and clustered indexes. Makes your indexes huge. So if you've got, big wide things that you're joining across, every time you've got a foreign key, you've got to slap that in other tables. So I would avoid using that wherever I could. Oh, next one. Oh, give that man a Starbucks gift card. Stop calling your girlfriend. Get back there and doesn't have a girlfriend. Yes. Next, where'd he go? Oh, yeah. Oh, the guy with the question was the P shirt, though, I think. Who had the original? Oh. Still hurting from last night. Go ahead.
Back on one of your previous slides, you had mentioned about DBA all, or just looking at
Missing index is DMV. Yes.
missing index as DMV.
Yes.
If you're doing that, aren't you fixing this problem?
No. The missing indexes DMV does not make recommendations for heaps. It doesn't say you should have a clustered index on this.
But you're creating indexes.
That doesn't fix the problem of not having clustered indexes. You can create indexes without having a clustered index. I've seen data warehouses with 10 billion rows in them, and they'll have several indexes on it, but the base table is still a heap. That's an absolute mess. There's another problem involved with that called forwarding records. So if you want to learn more about it, Google for Heaps or Bing, whatever your favorite search engine is, for heaps and forwarded records, and you can see the problems associated with that.
You're already pimping out your iPad.
I'm already pimping out the iPad, yes. Over here, somebody raised their hand. Oh, you again, yes.
Using that tool, in my experience, is a very bad thing because the guy before me,
What was a bad thing?
looking at the DMVs for
Yes, for missing indexes, yes.
over time you'll end up with a database that's got an index on every column.
Yes, I have on my site. I explain how to use those correctly. There's also an index or DMV on indexes you should dump It's not called that, it's called index usage stats. But it'll give you the reads per write ratio, and you can see when an index has been written to a bazillion times and it's never actually been read. And I've got a link to that query that even gives you the drop index statements you can use. All right, more questions, go ahead, fire away. Oh, you're gonna have to speak up. This isn't, you can't whisper in my ear from back there. There's the religious zealot. Yes. Yes. You're experienced and I'm not? What? Call me when you're up here. Who said that? No, I won't have this argument here. You can come back up afterwards and we'll talk about your experiences versus mine. I am buck by proxy, yes. Yes. He said, I speak from experience. And I said, oh, I speak from France. Yes. Okay, so first off, the first thing I want you to get you to do is start looking at identity fields. But if you don't have those in the table, because often you won't, start asking questions of the business users and say, what makes a row unique in this table? And if they tell you there's really nothing that makes a row unique, you'll say, you're an idiot, and go find me somebody who does know the data. Or you can tack on an identity field. I'm fond of that too. Number 3, now we finally get to the missing indexes, DMVs, ignoring indexes. Now, we think of our development projects as these things that have a fixed start and a fixed end date. And when we cross that finish line, like a highway project, everything's gleaming and we can walk away from our jobs. And it never works that way, because 2, 3, 4 months later, somebody else has a completely different usage pattern for this database. They've written totally different queries. They've decided to add new reports, none of which match what you originally had. So there's no such thing as being done. In order to scale your indexes, whenever you go live with an application or whenever you take over an application from somebody, I want you to pick a business statistic about the data. Not a sheer database statistic about the number of rows. Pick a business statistic like, how many sales did we do in a month? How many end users did we have on the system? How many reports were run? Something that I can monitor from inside the business, but something, or inside the database, but something that means something to the business. And I'm going to go to my business guys, my project manager, and say, all right, right now we're doing $100,000 a month in sales. When this application has $200,000 a month in sales, when we've doubled, I need time to come back here and look at these indexes. I need to run the missing index DMVs to find out whether or not I need to make changes about my database. And you want to do that because your business people will understand, and because you can frame it to them as just like a warehouse. If you had a warehouse out there that was handling all of your products and suddenly you were moving twice as many products through it, you would probably have to go back and look at how you were racking and stacking things and how the floors were laid out so that you could cram everything in there you wanted to cram in. And I want you to revisit these periodically, and the way that you do it is start by, as you talked about earlier, removing indexes. Never start by adding indexes. Run the index DMV queries that I linked to in the show notes to say what indexes flat out aren't being used at all. Because all they're doing is slowing me down every time I do an insert, update, or delete, every time I do a DBCC, every time I do a backup, or every time I do index maintenance, which your DBAs are lazy. They may not be doing index maintenance. I'm still preaching on them how to do that. Only after I've removed all the dead weight, all the indexes that aren't doing me any good, then I go use the missing index DMVs and add stuff that I think is appropriate. And I've got a video tutorial on how to do that on my site, how you make judgment calls about which ones are going to have a high ROI and which ones are not. Yes?
Quick question. If you use the reorg index, rebuild,
Yes.
does that affect that missing index stat?
If you use good question. Okay, so if you rebuild your indexes with defrags or reorgs, does that affect the missing index stat? No, there are two, when you're looking at those DMVs, there's two sets of statistics. There's user questions, or user reads, seeks, scans, whatever, and then system writes and scans. And the queries that I've got just look at the user ones. So the system numbers will artificially blow up, but we don't care about those. Not that I'm aware of. Not that I'm aware of. Now, when you drop them and recreate them, yes, that will. But All righty. So the queries to do this, you don't have to take notes, of course. Oh, I got a question in the back.
Something that doesn't get queried that often. Can I create my index and drop it?
I couldn't hear you. What's that?
Something that doesn't get queried that often, like once a year.
Yeah.
Can I just create an index, run my query, and drop it?
Sure. I was just in a client a couple of weeks ago where they had a. Yes, okay, so the question was, I'm up here with my megaphone on. The question was, if I have a query that I don't run very often, can I create the index, run the query, and then drop the index, if that makes a significant performance improvement on the query? So I had one developer I was at recently had a stored procedure where he first created an index inside the stored proc, ran the query, and then dropped the index. So in theory, that works great, right up until somebody loves your query and decides to start running it all the time. They had started doing this on a scheduled task every 15 minutes to email them whenever the numbers changed. In 2 weeks, this index had been added and dropped because of this. I counted the number of times the stored proc ran, 64,000 times in 2 weeks. I said, you might want to leave that around. So if you're doing this, yeah, this is my life. If you're doing this in a text file on your own machine, fire away. But the instant you embed that in either an application or a database in the form of stored proc function, UDF, whatever, don't just leave the index in there. If you really need it, leave the little fella in there. Besides, then we can make the judgment call later as to whether or not we want to use that or drop it based on the missing index DMVs. And there's a catch with these two in that it's the CIO query or the CFO query. You know, you've got these executives who run a query, they only do it every 3 months to look at sales over the last quarter, and you know you want that thing to run fast because it's your boss's 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 boss. And I've got in the video on how to use this that I've got links to on SQL Serverpedia that walk you through exactly how to do this and how to know when you should ignore these and when you should use them. So the results that you get out of these DMVs, I like to store these in Excel, and this is what the output looks like, and I'm not going to show you how to read the output, but the reason I want my DBAs to use this is that I want them to save these so that if they keep redoing their index tuning every 3 months, 6 months, whatever, they can go back and say, oh, I used to have an index on here, but I dropped it because it really wasn't that effective. Because whenever they go to add new indexes, I want them to check and see if that index used to exist or not. I call it leaving a breadcrumb trail. Whenever I drop an index or whether I want to decide to keep an index, if I know it's like a CIO query, I don't want to keep it around or do want to keep it around. I want to take notes so that I'm not relearning this thing every time. Because I don't know about you, but I may not remember what VPX hist stat 2 is when I'm going to do index tuning. Coming down the home stretch here, the second to last thing that just worries me when I see people trying to scale is TempDB. Now, TempDB is like duct tape. It does work fine when you have certain needs, but I don't want to see it holding an airplane window in. It is temporary. It is very temporary. That's the reason why it's called TempDB. The thing gets blown away when the SQL Server restarts. It doesn't get rewritten to. That's a separate question. But it is also shared. Now, here's where things get a little tricky. When you implement your application 6 months or a year from now, you think you've got your own nice, pretty little server because your project was so important. Well, 6 months, 12 months down the road after you've been laid off, and I know you don't care what happens when you get laid off, but after you get laid off and the company's gone through this huge cost-cutting and consolidating thing, they're going to pour all kinds of other databases on your same server. Or your application won't take off as fast as you thought, and some other project manager is going to say, oh, just reuse Johnny's database server. Add another database on there because it's got plenty of space and capacity. TempDB is shared not only between applications, because you may have application A and B both creating TempDB on the same server, but it's also shared with SQL Server itself. Your database administrators can do things like rebuilding indexes in TempDB, which will impede your performance while that's going on. If you use things like snapshot isolation, there are versions that are stored in TempDB, and it'll undergo heavy activity. There's a lot of things that you're competing with SQL Server now for resources instead of when you were in your own nice self-contained database. And the way that I want to work around this is, if you really have stuff that you only need temporarily, but you rebuild and throw away all the time, consider building a temporary database for your application. And what that does is it gives the database administrator the flexibility to put that on different storage depending on how your application, whether your application is critical or not. Because if your application is loved by executives, that may give you the ammo to go back and get nice fast database, nice like Fusion IO solid state drives for your TempDB, but not for the overall server where you're competing with other applications and things like index rebuilds. And then finally, my very favorite thing off of my things that won't scale, and this is where I started coming back to the link and entity framework stuff, is version 1 features. Sometimes version 1 things take off and they become massively popular. Everybody loves to use them. They're a smash hit. They get all kinds of development time. You know, this is Steve Jobs' old keynotes where he actually had an old pedestal up there on the stage. You know, how different are things today? That thing looks completely different, and we all know and love these, but it's not always like that. Who remembers what this is? Who said QCat? Who said Q? Oh, the guy with the hand up back there. Give that guy a couple of Starbucks cards because we still got a pile of those. Look how proud he is. And where did you get him? And he can't answer. Who else knows where you got him? Radio Shack. This guy up front here. He gets another 2. So what these deals were, they were called QCats, and you got them for free at Radio. I think they were free or like $5. Were free from Radio Shack. And the idea was that you would plug them into your computer, and whenever you saw an interesting thing in a magazine, you go, oh, wow, I sure would like to learn more about this cat food. You would hover the QCat over the magazine, scan a barcode, and it would launch the right website on your computer. Right. Well, as it turns out, people don't really like to carry these things around them when they read magazines. Sometimes they tear things out. Sometimes they, want to write things down. And this is like the predecessor to tinyURL or Bitly today. If you'd have built your business on top of this, just as Radio Shack did, you wouldn't have made any money. And I see people making these same mistakes with SQL Server today. Right. So if you're going to be an early adopter and you're going to go buy Segways for your police department, first off, expect bugs. Whenever something comes out, don't expect it to be bulletproof right away. Don't embrace it and immediately say, I'm going to make this the centerpiece of absolutely everything I do. Oh, and by the way, it's never seen anything anywhere near of a scale that I'm trying to build it out at. You don't want to be the first guy to put a 10 billion row table into whatever it is. You don't want to be the first guy who tries to break records with whatever that feature is. Just because it works doesn't mean it'll scale. Give it time to go through and get all of the other early adopters out there to make those mistakes. But if you insist on being one of those early adopters who dives into link, entity framework, whatever it is, and I have no problems with those. I work with people who love them. But you want to meet your peers, whether it's through online groups, forums, Twitter, whatever, and just like we saw back here, know who they are so that you can ask them questions, because otherwise you're going to keep reinventing the wheel going, oh, I wonder how this works. And you've got dozens or hundreds of other people trying to figure out that same thing at the same time, and they can say, oh yes, that's a bug over here on Connect on this page right here, come vote for it for me so we can get this thing fixed. And you want to expect to, whenever you're using features like this, expect frequent rework. And I have a lot of you guys out there going, well, that doesn't really affect me. I'm using stuff that's pretty normal and stable, and SQL Server doesn't do it all that often. Think about SQL Server notification services, English query, DTS. There's all kinds of features that have been what I call one and dones. That maybe I'm not so sure I want to invest my entire business in, say, master data services, something that came out in a version 1. Hopefully there's no BI guys here to hear me say that. But let somebody else do that scaling for the first version before you go pour all of your effort into that. Now, there's a few things I'll touch on too quickly for a bonus round. First off, CLR. This is another one of those issues where if you're a genius like Adam Mechanic, you can pull this off and scale it like crazy in your database. But if you're like the second picture I showed, maybe you're not quite as skilled for pulling that off. Cursors, I love cursors, but I don't expect them to scale. I don't expect to take them into multi-terabyte databases and expect them to fly. And then finally, as developers, small data sets. This is the old worked on my machine trick. If you have a stingy database administrator, get him to give you a development server that's a copy of production on the slowest SATA drives you can find. I used to tell my developers here, this is a boat anchor server. It's dead slow. It's got everything's RAID 5 SATA. It's got almost no RAM. If you can make your app fly on there, on the full-size data, it will fly in production. And my developers, and I don't want you guys throwing anything at me, but I know how you think, and you go, but production has so much more power. Sure it does, but there's more people using it, and there's more people just like you writing queries against it, and you're going to have to share that environment. So you want to learn with the full-size data sets, but on the crappiest hardware you've got in the data center. They should give you really nice desktops with 30-inch monitors, though. So to recap, first off, you're not Einstein. You're here because you're struggling to learn just like the rest of us. Set yourself up for success by using things that are known to scale really well instead of just trying something that maybe works on your machine but doesn't scale to full size. You want to avoid version 1 until it scales, meaning future-proof your code. Don't put something into place that you're going to have to rip out, turn around the very next version because all of a sudden that feature got deprecated in SQL Server. You want to know that it's something that will work permanently. And then finally, you can learn more at brentozar.com/go/scale, where I've got links to all of the scripts that I mentioned here, the missing index, DMVs, video tutorials, yada, yada, yada. That sums up everything I've got. So if you want to make a mass exodus for the exit, you can, or I'll take questions until they throw me out of here. Can I show you the iPad picture again? The iPhone picture? Was there iPod? Thanks, everybody. Thanks for coming. Appreciate it.